when we upload notes, it's getting way too, and for you guys it's normally okay because I'm coming back from lunch, but like when I have to transition between classes and pull up a new Smart Notebook file and stuff, it's really time consuming, and especially when my computer decides to not function correctly. So from now on, this will be the first page of your notes. So the notes file is going to have notes from every single class. Your guys' notes will be the last on every day but Friday. So on Friday, I have Math 7 first, so it'll say Math 7 at the top. What are you looking for?
I need the 6 notes.
6 notes.
I need the notes and the homework. I wasn't.
We started it 2 days ago. Are you sure?
Oh wait.
I know you weren't here yesterday, but I think you were the day we started it.
Yeah, you have it.
Yeah,
Oh,
exactly.
I'm supposed to have it. Okay.
I think you should. If you don't, I'll print you one. But so once you then scroll through, and you can see on the left-hand bar, there's all the Math 7 notes. We were doing solving equations, dirt formula. Do you remember all that stuff? Now here's your guys' notes. They say Math 2, what we're doing, homework 11-7. I don't expect that we necessarily finish this lesson today, so just go ahead and start it. And then this is totally worth checking out for a minute. So our special cases. So I'm going to put this up on the TV. A perfect square trinomial is when the a, and I'll just put this back down here since I'm going to discuss it for a second actually. When the a value is a perfect square and the constant value is a perfect square, and what's more than that is the value of a and b multiplied together, to give you your middle. And we're going to look at examples of this, and that then solves out to a plus b, or a minus b. So they're the same binomials, and when they're the same binomials, we can just write it as a binomial squared. So an example of this, let's just play with this for a minute. If you want like scrap paper, just write this somewhere on whatever you got. If we play with this for a second, I'm just going to zoom way in so I have some blank white space. Pick a binomial, and you don't have to pick the same one as me, but say we had x plus 3 squared. When I write that out to FOIL, it's x plus 3 times x plus 3. Lynn, did you find them? Did you have the 11.6 stuff? So when I FOIL this, I get x squared plus 6x, because I would get 3x from the outside, 3x from the inside, plus 9. So that, if I had this to start as my trinomial, would work back to your binomial squared. So it's easy when we start with the binomial, obviously, to get the trinomial. It's harder when we have the trinomial start and we work to the binomial. The other example is a difference of 2 squares. So what this is meaning, you guys all right, or do you need something? Oh, yeah, you're just talking about it. The difference of squares is saying if I have 2 values, so like, let's say x plus 3 and x minus 3. So it's a difference of squares because these values are the same except for one is positive, one is negative. Will you pull out the earbud, please? I know you can probably hear me, but it's just a respect thing. Even when you're talking with your friends, guys, it's really rude to keep your earbuds in. So we would get x squared plus when I do outside and then I do inside, what would happen there? Disappears. Because I would get a positive 3x and a negative 3x and poof, it's gone. So I just end up actually with a minus 9. So that would be, it's not a trinomial because the middle term is gone. That binomial is just your answer.
Wait.
So that is an example of a difference of squares.
So are we just doing...
We're going to cover all this. I'm just giving you a couple examples to start.
Alright, cool.
Yeah. Just to get our brain back into where we are. So, I need to adjust this back down a little bit. If we then, sorry, do you guys have any questions from 11.6 first? That's where we're going to be headed. What the heck?
You put it down to 10%.
Yeah, but apparently instead of tapping the minus, I tapped the bar. Any questions from the 11.6 homework from last night? This guy.
Yeah.
Yeah? What do we got? I'm going to need something to write on here. which one gave you some trouble? Carmen, which one gave you trouble?
The 19, 20, 21, and 22. I'm kind of confused, like.
Ah, okay, sweet. Yeah, somebody came and asked me about these. But what we're looking for with 19, 20, 21, and 22 is if I start with 4n squared, I have something that adds with or some coefficient to my n value, and then my minus 3, I can start to factor this out without knowing the middle term because there's constraints on my binomials. So when I set up my binomial times my binomial, I know that I can either have 4n and n or 2n and 2n. And sometimes it's good to write out both options and play with it till you figure out which one works or doesn't work. Because process of elimination is fairly useful. If I had 4n and n, then I need to make this negative 3 with my constant values. What do these constant values in the binomials need to be? Negative 3 and 1, or negative 1 and 3. So let's just say I'll do a positive 1 and a negative 3. Does that work to get my 4n squared? Does that work to get my negative 3? So then what does the middle coefficient have to be? Well, negative 3 negative 3 times 4n, negative 12n plus n, if we use the 2n and the 2n. I still could do like positive 1, negative 3, or... So, let's say now I do negative 3, I did do negative 3, but it doesn't, yes, answers can vary, short answer. If I do a negative 1 and a positive 3, does that work to get my negative 3? Does it work to get my 4n squared? So then what's your middle coefficient? Well, this would be 6n minus 2n, that could be 4. If this was positive and this was the negative, well then I'd have negative 6 plus 2. I could have negative 4. Sorry, my orientation's off.
This is very open.
So, pretty sure the answers there could be positive 11, negative 11, or positive 4, negative 4. There's normally like 4 different answers. Well, there's 2 different answers and then both signs of that answer.
Well, I also got 1 then.
So there's not just one right answer. So are you saying you got the number 1 by doing which? Because there's other manipulations.
I did n plus 1 and 4.
Sorry, n plus 1 and 4n minus 3. The negative 3, the 4n squared. So then negative 3 plus 1. Yeah, so 1's another option. So it all depends on how do you build your binomials. So there are many answers here. As long as it works for the 4n squared and the negative 3, it's fine.
I think there's 8 options.
It depends on, it gets tricky with which is positive and which is negative. That is what limits how many options you have. And I forget what the rule is. So I'm not going to make any.
I think it's a combination of, I think it's based on the number of pairs of
Factors, yeah.
I bet it's 4 times the number of pairs.
So do we want to see another one of these for good measure? So if we did 20, I'm going to make you guys help me more this time though. Now that box is completely missing everything. It doesn't even have the variable. So our answer there is going to involve the variable potentially.
Wouldn't it have to be because it says the trinomial?
Unless it came out to be a difference of squares like we just saw up there, there's going to have to be a b term. So there will eventually, not here in 11.6, but there will eventually be times where this is nothing, but not in this scenario. So to get the 12R, I have a bunch of options. I could use 4 and 3, I could use 2 and 6, I could use 12 and 1. So if I do, let's just say 2 and 6, just random choice, what then other constraint do I have? Ethan?
Positive 6.
Positive 6 at the end. So how could we get that?
Positive 1 and positive 6.
Sure. So this gives me 12R. This gives me, 6R, these. So I get 18R is an option. We could also, what if we did like 12R and just R? And then what if I did like 2 and 3? Or I could do -2 and -3. I could do -1 and -6. So there's a ton of options here. This would give me 36R plus another 2R, so that would give me 38R.
I'm that one.
I'm writing my formula.
Okay. We could work this to the point that we could derive a definitive.
I think it's not the number of factors of A,
Okay.
pairs, times the number of pairs of factors of C.
For how many options there are total.
Yeah.
I would want to try that out a few times, but that sounds like it would probably work.
Times 4.
So you said the number of factors times number of factors times 4. Maybe try if you want to over the weekend, play with it, see if it works. Other questions? The positive, negative
And then
options.
also what numbers are paired in which.
So I could do +2, +3, -2, -3, -3, -2, +3, +2. There are 4 ways to arrange those 2 digits if you are switching places and switching signs.
This just basically is making it easier because it gives you a lot more room to work.
And it's making you see that like there are umpteen, like there's like infinitely many ways that these things pan out, these trinomials and all that sort of stuff. And what this center term is going to tell us, and like how it derives from these values, again, is the shift on the graph. Is where is that minimum or maximum of the parabola? Where's the line of center, like the axis of symmetry? And we'll get to all these vocab things. Where's the directrix, which is a horizontal line that's either outside the parabola or through the parabola? And then where's the focus, that point that we talked about, like the light bulb in the lens? Other questions from the homework? Not good wait time unless it gets awkward. All right, let's do 11:7 then. At least a little bit.
Yay!
Wait, I have something to add to my quote list. Can I do that?
Sure. What is it?
I can't tell you what's on the quote
Oh
list.
yeah, because you tally them.
No, I tally when you say I trust you guys.
Oh. Well, I did.
You're supposed to have a
Well,
little.
then I have to.
Oh no. So it's because yesterday you guys already had the notes. And
Two things to add.
you are welcome. So I feel like I just taught the class before you guys the best lesson I've ever taught on converting temperatures. And I don't even know if you guys know this. And I'm curious because this just popped back in my head to see, do you know where this came from? When we do the temperature conversions, and actually I can do this really easy. What? The 5/9 or the 9/5? Do you know where that fraction comes from, though?
Let me hone my senses.
Where do we get the 5/9? Where did we get the 9/5? Why do we use those? That's the question.
American.
Emma?
Because for Celsius and Fahrenheit, the boiling point is 100 to 360.
What?
Well, I'm not entirely sure what we were talking about because I wasn't paying that much attention.
Yeah.
I thought it was temperature conversion.
Yeah,
And
yeah.
so for one, the boiling point is 100, and for the other, it's 360. So I don't know if it has something.
Ooh,
to
it's
do with
not 360, it's 212.
it.
So this was the problem that I was talking about with my 7th graders. How do we use this formula, and then how do we derive a formula for Fahrenheit? You guys know the Fahrenheit formula is 9/5 C plus 32. So we use 5/9 or 9/5. But I realized that I never knew this until a couple years ago, so I feel like a lot of you probably don't know this. The reason we use those fractions are because the distances between freezing and boiling.
You know, I was gonna say.
If you set up the ratio of 180 compared to 100, that's 9/5. If you set up the ratio of 100 compared to 180, that's 5 nines. So it's the distance between them.
Oh.
That's what we're comparing, is the distance between them. So this span distance compared to this span distance in ratio makes these fractions. That might just win you $1 million someday.
Sure about that?
No, but it might.
But then also you could get.
You what?
I would. That's what from my locker.
All right, so those two examples that I gave you guys when you walked in, your perfect square, I would underline these so they stick out from each other, and your difference of two squares. Here are those examples written out in the algebraic form. So just like that image on the start slide, bless you. You've got those same sort of examples, and then you've got some numerical examples with it as well. So if we had x squared plus 8x plus 16, we can break that down into x plus 4 and x plus 4, because 4 squared makes 16, and 4 doubled makes 8. When we have a coefficient on the n squared, that changes things slightly, because then my values that start my parentheses both need to be the same. So I know that my 4n squared has to be broken into 2n and 2n. That, like, if we're trying to do perfect square, that has to be it. I can't do the 4n and the 1n. Then I have to see, well, what is the square root of 9? Well, in this situation, to get my middle term negative, I have to use the negative square root. Because remember, square roots have the positive or the negative options. In difference of two squares, this probably makes a little bit more sense than the other. When we don't see a b term, that really indicates to us there's a difference of squares that has happened. So you're looking for what binomial can multiply by itself with the only change of that middle sign. One's got to be addition, one's got to be subtraction. Yeah.
Why does that one say for every real number and that one say for all real numbers?
Pearson. Yeah, I don't know. Because I bet you 2 different people made those boxes. Like one person made this key concept and another person made this key concept. So, we see a perfect square trinomial. We can identify when, and this is sort of like where you step back and look at things. This value and this value should be related through one single term that when doubled makes my coefficient here, and when squared makes my constant here. Cool. So what we realize is, what's that number? That doubled makes 12, that squared makes 36. 6. But it's got to be negative because of the negative 12. So we then break this up into the fact that we can realize, and they actually leave the negative over here, so they actually don't do this quite the same. But if we want to jump and forget about their little third step here, what would this turn into? So you guys said 6. So we would have x, negative 6, not times 2, squared. You just square the binomial. So that's why we call it perfect square trinomial, because you are squaring the binomial, which gets you the trinomial.
Okay.
Not every trinomial comes from a binomial squared, but the perfect ones do. Question or stretch?
No, it's just-
Stretching or question? That it kind of rhymes.
I mean, you could put it in a song.
Try the got it on your own. What number doubled gives you the b, and when squared gives you the c? And Mr. Straveler, you're on top of the stack. What number would that be? Trace is correct. So this just becomes x plus 3 squared, because this is positive and this is positive. We're good. Yeah.
After you draw my name, does it go in the bottom of the pile?
Yeah. I mean, because unless I shuffle and it comes back up, and then I just kind of float it anyways. So, on a digital camera, well, really any digital image at all, is made up of pixels. And pixels are tiny. And that's why up here it doesn't look as good as some of the other boards, is this projector is not as new, so when it throws the pixels, like every pixel is individual, it's just not as crisp as some of the other ones.
Crisp.
So you got the bad one?
This is just the oldest one in the school.
Are you getting an upgrade?
Maybe eventually.
You use it the most, don't you?
Not while we're here.
Pretty much.
We will-
Yeah, it won't be while you're here. So digital images are composed of thousands of tiny pixels rendered as squares, shown below. And I did not put the picture there. Suppose the area of a pixel is that trinomial. What is the length of one side of it? So when we see one of these problems, and we know that the first value, my 4x squared, can be written as its square root, like I can write it as 2x squared, that should kind of kick you towards thinking, is this one of those special trinomials? So I think of this as 2x squared. That's going to start to set up my binomials of 2x and 2x. What else would I need to have? Ethan? Something that multiplies to make a 5. So if I put my 5 here, then I'm still constrained to have, is it plus 5? Yeah, sorry, so this, because they've already broken down that this is 5 squared, that's your term that goes in both. Now check it, 5 times 2, 10x, 10x, so it's really just 2x plus 5 squared. When you can see your A is a perfect square and your C is a perfect square, that should work out, hopefully, if the B value cooperates, to be a perfect square. What do you mean? Oh, man, when I used the Pearson lesson, it had the image, and I think it was, I don't know. I forget what they were going. They might have been actually tiny. They might have been like, yeah, ridiculous things like that.
Is that different than nanometers?
Well, I guess a nanometer would measure nanometers.
So is that smaller than nanometers?
Yeah, like a micrometer is what you use in cars,
Micrometer?
but you say it as a micrometer. It's the object that
That
measures.
sounds like a weapon of mass.
So try this on your own. What's up? Oh, she went to the restroom if you were looking for her. You want to learn how to factor a perfect trinomial?
No, we do that over there too.
Yeah, I'm sure.
Yesterday with somebody. Have fun.
Will do. Yeah, that is funny because they do teach the same thing over there. So if I look at 16m squared as what would its square root be? What would 81? So try this on your own. I'm just kind of talking while you're doing this. It will help you conceptually if you write their square roots first. So to think through, it's this squared and that squared, and that then is what I use. I'm sure you're getting everything that you're missing.
Yeah, I wasn't there for that part.
You can glance on somebody else if you want. Not at all. What is the square root of your A? Caleb?
That would be 4. Oh, actually, yeah. Well, sorry, yeah, 4M.
Well, yeah, so if I write this as 4m squared minus 72m, and then square root of 81, 9, or,
Negative.
and in this case, which are we going to use? The negative 9. So we're going to write this as plus negative 9 squared. Like if you're rewriting out the trinomial to think through it. Because then all you use is this value and this value as long as your B value cooperates. So let's check. Does it cooperate? Come on. So I'd have 4m minus 9, 4m, crap, minus 9. I wish I could still erase with my hand. That was really convenient. What's negative 9 times 4?
Negative 36.
And when you have another negative 36, we get negative 72. So this is 4m minus 9 squared. These, even though it takes a little bit more thinking and analyzing, should be easier because there's really less work to do. you don't have to make any choices. If you see that that's a perfect square and that's a perfect square, sorry, that's a perfect
Good
square,
morning, Cassidy Oyer, please
and that's
come
a
to the
perfect
office.
square.
Cassidy Oyer to the office, please. Thank you.
everything's decided for me. I don't have to choose any values. I don't have to think really. I just have to figure out their square roots. I mean, like, at least I personally feel like there's less thinking involved in these than in yesterday's lesson of having to derive everything all on your own and make those choices and figure it out. Yeah.
It's funny how both of the numbers that we got are also perfect squares.
Mm-hmm. Yep. So this could be like, well, it'd be 2 squared m. That's the problem, is that this has the variable on it. Minus 3 squared. Yeah,
So
that is
if you
funny.
reduce it even further,
No.
drag.
I mean, you could, but it wouldn't be.
If it was m to the 4th,
Yeah, it wouldn't be like, no. I mean, you could rewrite it in a different way, but that wouldn't be simplifying it, so we wouldn't do it. We would only do it if it would simplify for us. Yeah, I have you guys till 38. So let's go ahead and flip to the back, actually.
Oh, County Board.
Okay, this is actually
Wait, what?
this is actually pretty
This is actually pretty easy. Now, here's where people will make their mistake because they forget that in a difference of 2 squares, you do have to have 2 different binomials. Because to multiply and make the -9, one's got to be positive, one's got to be negative. So still, you're thinking square roots. I can think of this as z squared plus 0z plus, or sorry, minus 3 squared. But really, we don't have to think through that whole process. Because I know that since this has canceled out, my outside and my inside cancel.
Wait, isn't there a parenthesis around the 3 though? Because it's not negative 3.
Yeah. So like that. But like, we don't even have to do that. Because what we're realizing is to get the -9, we're not looking at this like we did the previous ones. Because we're not going to square the 3. Like, we could do it like this, but we've got to cancel out the 0z. Or we've got to get z to cancel out and become 0. So if I do z, z, 3, 3, we're done. Again, no thinking. Once you derive what's the square root, so for here, Brian, if this is your favorite topic, what binomials do we end up using?
Call them.
Square root of 100.
Okay, 10.
So my binomials become,
V10 plus 10 minus 10.
yeah, v plus 10, v minus 10.
I say you flubbed that mine. I was thinking of
Hooray.
near the end of it. I was thinking of that.
This is a pretty good lesson to end the first week back from break.
Like, I can do this.
The 0 thing lesson. No, nobody.
Now,
Like,
now, what happens, go to Michelle, when there's a coefficient on the x squared for a difference of squares?
Well, then, that coefficient, the square root is 4, so you can do 4x minus 9 times 4x.
Could I do 16x and 1x? No. Because there's no b value here, my binomials have to perfectly match except for that middle sign. That's the only thing that can be different. So whatever happens here with a plus has to happen here with a minus, or vice versa. So square root of 16x, 4x, 4x, 9, negative 9. Take a second, do the got it. I'll give you like, I don't know, 10, because most of you guys already have it. Actually, I'm going to rewrite this since it just did not capture.
And it doesn't matter what order you put the negative
Nope.
and positive.
Does not matter.
Only you have one.
And actually, all right, I'll push you one more step then. So the order of which, like, where the plus or where the minus is doesn't matter, but so those are the same expression, right? Like if I apply the commutative property, it's still the same expression. are there any other expressions, like binomial times binomial, that could solve for that, aside from the 4x minus 9 and the 4x plus 9? Yeah, but that's still the same expression. If you use the commutative property.
4x and the 9.
So you mean like negative 9 plus 4x?
Yeah.
It's still the same. Because that's still commutative property. So commutative property doesn't change it, it just changes what it looks like.
Could you reduce the x again?
Will this get your 16x squared?
Yes.
Will these cancel each other out?
I expected a little bit more like convoluted.
No. Like, so when you're thinking through, and this is just that analytic, because we don't know what's all going to be on the air test. So if they gave that to you and they gave you that one and they said provide another expression that would get you, you got to be able to think through, if I change both of these, it compensates and corrects itself. So yeah, just making you think through, there's not just the one option. I can always play with those signs. Yes. Window opens like April. It might open in March. Yeah, the window might open. I'm not so. But when we get back from spring break, it's like the spring to the finish.
No, for me, like the science is gonna be really bad.
First time that's around. Scarlett, what did you get for our factored form for 25d squared minus 64?
I got 5d plus 8 parentheses, and then in a separate set of parentheses, I got 5d minus 8.
Absolutely correct. Any questions up to this point before we move into factor 5 or problem 5? So now, just are you guys figuring out the seating charts?
Yeah. We're just discussing who sits next to
Who Brian cheats off with during time.
I don't know what they're even talking about. So let's wrap this up, because then we'll still finish early. What's the factor form of 24g squared minus 6? Just like any of our polynomials, if we can make it easier before we start, why not go ahead and do it? So, yeah, I could factor out a 6 to begin with, and I could say this is really 6 times the quantity, 4g LTE, minus 1. Is 1 a perfect square?
Yes.
Yes. Is 4g squared a perfect square?
Yes.
So,
12g squared.
I'm missing the middle term. So that tells me, is it a perfect square trinomial or a difference of squares? Difference of squares. So we're going to have the 1 with the plus and the 1 with the minus. How do I get 4g squared? 2g and 2g. How do I get my negative 1? Up 1 and a negative 1. You could if you wanted to, but we would really just leave it right here. So when we get to actually plotting these, hey guys, you might want to care about this. So Michelle's asking, so then would we write this as the 12g minus 6 and the 2g minus 1? Or,
One of those is a plus.
sorry, that. You could, but we would normally just leave it right here. When we get to the graphing part, so when we get to graphing, this tells you some things, and this tells you some things, and it's kind of one of those, what choice do you make? Because what did we talk about with what this binomial and this binomial can inform me of? What it could find on my graph. Find my zeros, right? So here, to make my function, so this would be some function f of g, to make that function equal 0, what would this value have to be? A negative half. Or it could be, what else? What would it be over here?
Negative half. Wait. No, half.
Positive
There you
half.
go. It's a half. I had to think about it for a second.
But hey guys, wouldn't those values have been the same of what I got here?
Probably.
So we'll look more at this as we start to graph the parabolas. But this is why I say you could leave it right here. The question I want you to ponder is, what then does this do?
Nothing.
Well, it can't do nothing. It's there, it's multiplying. If you had like a number riding along beside you, I don't think it would do nothing.
This makes it bigger.
What do you mean by bigger?
It's the same thing. It just makes the numbers bigger. Wait, does it like make the thing bigger? Like
It changes the intensity. Well, there's a lot of different words that people use. I like to say intensity, like how tight or how wide it is. That coefficient to the whole thing, all it does is change your like slope in a way, your steepness, whatever you want to say. It's dangerous to use slope because the slope's normally used for a line. But yeah, whatever you want to say about the parabola's size, that's what that 6 does. It does not change where the intercept points are, where the zeros were, because I would have gotten the same thing up here. It would depend on what you were doing. Like, so if it wanted, if it asked you show this as a difference of squares, then you would want to show this one, because you've got the 2 binomials that are the same except for the sign in between. If it said just show as the product of 2 binomials, then you'd want to use this one. But you would probably do this first, I mean, if you realized to factor out the 6, and then get to here. So it would depend on what the question would ask.
Would you take both of them?
I would, but she asked what would be best on the air test. And I said, depends on how the question's phrased. Caleb?
Question, why don't they wait to do the air test until the end of the year?
Some schools release earlier than others. Some schools start earlier than others, and they have to have time to get in makeup tests and everything else.
Okay, but like then it was like for like a math thing, what if you just hadn't learned the content yet?
I agree.
So they wanted to do it like after like the second last week. That way you can do it.
I agree. But what do we do second to last week of school? 7th grade's in Chicago. A lot of 8th grades go to DC. A lot of high school people are like on walkabouts or whatever their trips are. So there's a window of the test, but that like you gotta get it in. So and technology restrictions. Some school districts, they have to move like computers building to building to be able to do this, because now all schools have to be online. Last year they had the option of paper or online. There was actually a statistical trend of schools that tested on paper tests did better than schools that tested online. They're like, the data shows those schools did better because they had the paper tests.
Computer no.
It stresses me out.
Yeah, just
I get anxiety.
yeah, but there's a lot less to worry about. You know what I mean? I have my test in front of me. I'm taking my test. If I'm on the computer, it's like, how do I highlight? How do I underline? How do I like? I got to go back to the reading. I got to click back as opposed to flip back. There's just, and it's one of those how. Yeah, it's like how likely would you be? I'm gonna go ahead and pass out your homework. How likely would you be to flip back and look at a reading, or click back and try to find the passage that you were like looking for, or like when it says specific paragraphs? I like being able to look at like there's my paragraph instead of scrolling through a screen.
But writing an essay, I'd rather do it online.
And our last got it here just to have closure before we go into the weekend. What, Calvin, can be factored out from 12t squared minus 48? 3 or 12. But if we want to go greatest common factor, we can factor out the 12. I don't know why you say you're still loading. So this could be t squared minus 4. Yeah, there's a lot of ways that this can go. But then this can become 12 times t. What would my values be then?
Plus 2. Oh, wait. See, I said plus 2 and you like, tricked me. I didn't know where we were.
I didn't trick you.
I said plus 2 and you didn't do anything.
I wrote it down. I
After,
didn't
like,
do
a
anything.
while after, I didn't say the number at
Patience.
that time.
So, if we looked at our intercepts here, for this being a function of t, that would equal 0 when t equals -2 or t equals +2. So, a trend that we've at least seen from these two to think about as we move deeper into our parabola work, those zeros were the same except for opposite values, like +1/2, -1/2. These zeros are the same except for one's positive, one's negative. So my question would be, does every difference of squares have zeros that are symmetric?
Probably.
So that would mean, if this is true, then every difference of squares has to be where on the graph? Centered.
Around the y-axis.
So we're hypothesizing, we don't know yet, we don't have evidence, but we're hypothesizing that anytime there's a difference of squares, its minimum or its maximum comes from the y-axis. So this is a question as we move deeper, is this always going to hold true? And that is all the time we have for today.
Ooh, awesome, man.
Enjoy your weekend. It's going to be kind of cold.
Same time.
No, sorry, evens or odds.
Straight.
Evens or odds on the homework. What? I'm so sorry. You spent 4 minutes doing it so far.
Alright. Bye, Mr. Hudson.
Wait,
He's like, same math time.
Well, you're going to
Same
have
math
sass with me.
channel.
I can have sass with you. What?
Next week, same math time.
Yeah.
Same math channel.
Actually, not